Hello, my sick friends. I hope you're doing well, or at least trying to get well. This is a video of our fraction review that we did today in class. I'll do it with you right now, and then we will hopefully see you next week for the big test, and we'll do a little review with you guys before we get started on that. But anyway, let's not waste any time. Let's get started. So I'm going to save this review packet for when you guys get back. What I want to focus on is this back page. So there's a couple small practice things down here, but feel free to pause the video, rewrite the question on some line paper, whatever you want to do. Follow along with me, whatever you want to do. But let's put what we learned the past couple weeks into practice, because we've been doing so well on fractions, and the kids that have taken these tests have rocked them. So let's get you to get there, okay? This first says, which expression is equivalent to 9/8? So if we remember our conversations in class, expression is the same thing as, somebody writing an equation, right? Something like this. And we know that Mr. Complement said that when we see the word equivalent, we need to make sure that we write the word same underneath. So we need to find one of these that has the same value as 9/8. So all we have to do is just simply add through these. So if you want to pause the video right now, do your work, and then check with me, this is a great time to pause. Okay, if you paused, welcome back. The denominators are the same, so I know I can add the numerators. 3 plus 3, this equals 6/8. Is this the same as 9/8? No. Okay, I have 6 plus 2.5. So I'm not going to be able to use this one yet, so I'm going to pause on him. I'm going to hit the pause button on here. I'm going to add these up, but you know what I noticed? These denominators aren't the same. I can't add these up. These denominators aren't the same. I can't add, or these denominators aren't the same as the one I'm looking for. These are 9s. I'm looking for 8s, so sorry, 9s. And then I have this one down here. I'm going to count my 8s. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 8s here. Now this half is a problem only because I can't convert a half into a third. And anyway, if I could, it's not the same as the 8 up here. So we're going to make sure this guy's crossed out too. Our answer is J. You got that right. Pat yourself on the back. All right, here's the next question. Ellie bought a pie. Well, she's got good taste already. I like Ellie. She ate 5/8 of the pie, which is the closest fraction to the pie she has left. First thing you're going to want to do is you need to look at the fractions that are available. You have 1/4 and 1/2. Well, I'm going to take a look at 5/8. Well, what do I know about 5/8? 5/8 is greater than a half because 4/8 would be a half. So 5/8 is greater than a half. So I'm going to take a look at here. This says less than a quarter. Well, that's not true. This says less than a half. Well, we just said half would be 4. 5 is greater than 4, so that's not right. This says about a fourth. Well, we know that 5/8 is much bigger than a fourth, so we'll cross that out. Well, the only thing that's left is about a half. And this is about half. It's actually a little more than half we're left over. So this is kind of how we do this. If you wanted to, you could compare them. So I could do my model here. Cut my model in half, so I have two fractions. I'm going to put my 5/8 up here. I'll put my 1/2 here. So here's my 1/2. And I'll do my 1, 2, 3. 1, 2, 3, 4, 5. Let's count how many lines. 1, 2, 3, 4, 5, 6. That should be my 8 now. 1, 2, 3, 4, 5, 6, 7. One more. 8. Now I need to color 5 of these. 1, 2, 3, 4, 5. And if you take a look, 5/8 is just over the halfway line for the half. So that's how we know that this answer is correct. So if you did that, awesome. That's how we're going to attack those problems. Now we're going to do these. I want you guys to pause the video if you are watching after I read these to you, and I want you to write these as a decimal. So here we go. Write 48/100ths as a decimal and write 6/10ths as a decimal. Go ahead and pause that video. Okay, you're back with me? 48/100ths. Say it to yourself. 48/100ths. There's a 4 in the tenths and 8 in the hundredths. 48/100ths. How do I write 6/10ths as a decimal? Well, I literally just put the 6 in the tenths place. That's why we say the strategy for converting decimals to fractions and fractions to decimals is to literally just say what you're working with. This is 48 hundredths. This is 48 hundredths. This says find the difference. And when we talk about difference, what are we asking ourselves? Elliot, Brinley, Jeremiah, you're sitting at home going, subtraction. And you're 100% correct. When we see the word difference, we know that we are subtracting. So let's set our equation up because we need an equation if we're using addition, subtraction, multiplication, or division. So I have 7/10 here, and I have 3/10 here, and it wants me to find the difference. Well, since the denominators are the same, my job's easy. What is 7 minus 3? Well, that's going to give me a difference of 4/10. 4/10. Pat yourselves on the back. You did great. All right. Last part of this review. Write 3 fractions that are equivalent to 3/4. And remember, when we see the word equivalent, we know that means the same. So 3/4. We're going to plug that in to our LCD table. Remember, this is something that we can use in 5th grade, but Mr. C is going to teach it to us now because it's something pertinent and we can use it. So remember, when we're finding equivalent fractions, whatever we do to the bottom, we need to do to the, and then everybody in the house screams, the top. So whatever we do to the bottom, we have to do to the top. Whatever we do to the numerator, we have to do to the denominator and vice versa. So let's get started. This first category here is multiplied by 1. So 3 times 1 is 3. 4 times 1 is 4. Now we're going to multiply everything by 2. So 3 times 2 is 6. 4 times 2 is 8. 3/4 and 6/8 are equivalent. Those are the same fractions. They look different, but they have the same value. The next box is going to be multiplied by 3. Now remember, we're not multiplying this by 3. We're going back to our original fraction. And if it helps you, box this guy. Put a star next to him. He's the special one. So now I'm going to multiply the top by 3. 3 times 3 is 9. 4 times 3 is 12. 9/12 is equivalent to 3/4. It is the same fraction. It has the same value. And then we need to do 3 of them. So I'm going to do one more. 3 times 4 is 12. 4 times 4 is 16. 12/16 is the same as 3/4. They look different, but they have the same, what, Elliot? Value. Good job, Elliot. Okay, let's read this word problem because we can have word problems in 4th grade everywhere. John and Andrew, man, that's a good name. John and Andrew read the same book. That's why they're the same size, as you can tell, so that same is very important. The shaded part of each model represents the fraction of the book that they read. Write an expression, and I automatically say equation, that can be used to find the difference between, what's the important word there, Brinley? Oh, you said difference? Good job, Brinley. Between the fraction of the book that John read and the fraction of the book that Andrew read. So we need to come up with an equation. Well, the first problem is that our fractions, they're not labeled. I need to find out what the denominators are in these books. So I simply just count my spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So our denominators for both of these books are going to be 20. How do I know? Why didn't I count John's? Oh, what was that, Jeremiah? You said that the story said that they read the same book? Great idea, buddy. Great listening. These are the same size, so we know the denominator is going to be the same. Now I need to come up with my numerators. Well, if I go back to the story, it said the shaded part represents the fraction of the book that they each read. So now I can come up with my fraction from there. So I'm going to look at my shaded part. The shaded part ends here. So I'm going to count 1/20, 2/20, 3/20, 4/20, 5/20, 6/20, 7/20. So Andrew read 7/20 of his book. Let's see how much John read. Well, I know what a here is 7. So I'm going to go 8/20, 9/20, 10/20, 11/20, 12/20, 13/20. That sounds silly. Okay, 13/20 is how much John read. So now I need to set up my equation. So I know that I'm subtracting because it says difference right here. So I know that when I subtract, the largest number needs to go in front. And I'm going to subtract from 13/20 what Andrew read, which is 7/20. and I'm going to come up with an answer. Okay? Well, I know that 7 plus 7 is 14, so I need to go one lower. 7 plus 6 is 13, so 13 minus 7 is 6/20, and that would be my answer for this problem here. If you did that right, great job. Proud of you. Okay. These ones, I'd love for you to pause the video, copy this down, and then do this on your own. Go ahead and pause the video now if you're going to do that, and then unpause it and join me in a moment. Welcome back. I'm sure you did amazing. Let's take a look at this first one. This says compare 5/6 and 1/2. I need to compare these two guys. Well, I can do a couple things. First things first, I can do my model. And I really want to encourage you, my friends at home, to do your models. Okay? Do those models. I'm going to label this 1/2. And I'm going to do the bottom down here into 6ths. Okay? So this says 1/2. And this is 5/6. Okay? Just by doing the model, I don't have to do any kind of sneaky tricks or get creative and cute. I know that 5/6 is greater than 1/2. Okay? Parents out there, if you're listening to this, you're like, I know a trick. I'm sure we do. And that trick does work, but we got to make sure we're doing this. If we're going to compare these, we can cross multiply. 6 times 1 is 6. 5 times 2 is 10. 10 is the greater number. So we don't really want them teaching this butterfly method until they understand how to do the models. Why does this is a great trick and it's quick, but in 4th grade, we're not worried about being quick. We're worried about knowing what we know and being masters of math. And this is what helps us get there. Okay, moving on. This says find the difference. What did you say, Julian? You said the difference means subtraction. You're right, buddy. Let's set up an equation. I have 8/12 and I have 4/12. And I'm going to subtract these two things. 8/12 minus 4, it's going to give me 4/12. And I'm going to do a little added challenge. Could you reduce this fraction or make it smaller? How could we use division and divide the top and bottom by the same number to make this smaller? Well, I just heard Elliot yell at the top of her lungs all the way from Post, Texas, Mr. C, divide it by 4. And I said, yes, Elliot, you're right. Let's divide this thing by 4 because that's going to make it reduced all the way down. 4 divided by 4 is 1. 12 divided by 4 is 3. 1/3 would be the smallest I could make this fraction. Great job, friends at home. Last box says find the total. That's a new one. We haven't talked about that yet today in their little thing. If we're looking for the total, what are we doing? We're going to add. We're going to add 2/8 plus 5/8. Well, I can add easy. That's easy. 5 plus 2 is 7. My sum of these two is 7/8. Thank you guys for joining me on this little review. I hope you have a great weekend. I hope you get some rest. Take your vitamin C, drink your water, eat your top ramen. Elliot, mostly talking to you. And we'll worry about this when we get back, and then we'll let you guys test on Tuesday, hopefully. Have a great weekend, and we'll talk to you guys later. Bye.